Hello, and welcome to today's installation of the SIG cluster lifecycle cluster API breakout meeting. Today, let's see, looking at the agenda, we're going to get started with a couple of items from Jacob. Dive right in.
Sure. Yes. Okay. So last week we were talking about machines and declarative nodes, and I sent out a PR proposal of a super minimalist start for this for how to create declarative nodes with some versioning information and where do we put provider-specific things. Some people had a chance to look at it and give feedback, which is great. I've addressed most of the feedback, I believe. But some kind of bigger questions before we get too far down that path are, let me look at what I actually wrote down. Right, so one of the things that has come up internally is starting with just a single machine, a single declarative machine, allows us to later build up machine sets and machine deployments if we want to, but are there any environments that anyone cares to support or can even fathom where it does not ever make sense to refer to a single machine and to just have, because a lot of other installers don't really worry about individual machines and just say, we have sets, we have node sets, we have node pools, we have just a scalable resource of homogeneous nodes that we want to not really refer to on an individual basis. So is that, does anyone see concerns with first starting with an individual machine object concept and then adding sets later? Or is there a reason to jump into sets, either completely omit machines and only work at the set level, and you can still have sets of size 1 if you want, or to not move forward with V1 alpha 1 unless we have both concepts? Like, anyway, sorry. If anyone has feedback on that, that would kind of kill the current design. And then if there aren't, number 2 was, are there any concerns with the capabilities that I outlined for nodes in that proposal? The very limited set of capabilities for V1 alpha 1, like the kinds of things that we want to target for the end of this quarter to be represented in the API and have working prototypes for anything that you think should be stripped out so we can be even more minimal, or anything that we're completely missing that you think is just going to halt us out of the gates and make this completely unusable.
I can just chip in on AWS. In my opinion, the machine set concept is more useful, but everything is still individually accessible or addressable and accessible. And certainly you will want to terminate an errant machine or, for whatever reason. So machines are good to start with.
Okay.
I would also just comment that even if we do, even if an environment does have just machine sets, it's probably still useful to have machines individually addressable, at least as status-wise, because that concept still has a lot of use. But I still am in favor of going down the machines first before we even start looking at sets, even if we do start reinventing a little bit of each cloud provider's wheel.
Cool. Yeah, I agree. I mean, I wrote that proposal. So, and I also think, certainly from a status standpoint, but also for the kind of tooling that we're hoping to support on a cross-cluster, cross-provider basis, if you want to think about an intelligent, safe cluster upgrader, if you only provide the functionality of upgrading an entire set of machines all at once because you can't individually address the spec of individual machines, then I think cluster administrators are going to have to preemptively think about, how do I structure my sets so that I balance them across availability zones and geographies and all these other things, because the granularity is only that I can upgrade an entire set all at once, versus if you do it at individual machine level, the upgrade tool could take a label selector or could just pick them at random and safely dial them up above the cluster API instead of shoving all of that below the cluster API into the provider-specific reconciler. So I agree. Cool. For the second question, let me actually just really quickly go through the use case of the capabilities that I outlined in that doc. And if there aren't any concerns, we can move right along. Otherwise, I can pause dramatically after each one and see if there's any feedback. Just pulling this up. Okay, so creation of nodes, individual nodes, given some sort of template. We want to, in a declarative way, be able to create a new node, including the version of the kubelet to run, the container runtime to use and its version, and any other provider-specific information like the OS image, the instance type, the disk configuration, all of that, even though that stuff will not be necessarily portable from one cluster to another. A specific node can be deleted, and the underlying provider controller should free any external resources associated with it. A specific node can have its kubelet version upgraded or downgraded in a declarative way. Similarly, a specific node can have its container runtime changed or its version upgraded or downgraded in a declarative way again. And a specific node can have its OS image upgraded or downgraded, and I guess any of the other provider-specific attributes, like you could change the type or whatever. And all of that, how it gets actuated is actually provider-specific implementation. So a really nice provider might try to upgrade the kubelet in place and make that operation really fast, but there's nothing wrong if a provider just says, well, every time you make any change to the spec, I'm just going to swap the VM and bring up a new one and delete the old one. So that was the full set of like P0 capabilities from a node perspective, not the control plane. Are there any that we think really need to be added right out of the gate, or are any of those superfluous?
I had a question about your thought that replacements could be in place or via replacement. If a provider can do some of these things in place, but some of them it can't, is there any way to indicate to the user, like, you're making this change, therefore it's going to be more disruptive than if you made this other change, right? Like, you're changing two fields in a declarative API, and it's going to have a very different impact potentially on your applications, right?
Yeah, so that's one of the things that I expected to be controversial with this proposal. There's no feedback from the controller, and there's no operation you can do in the spec to say, I only want an in-place upgrade or in-place replacement or in-place actuation. You can force a replacement because you can always delete the machine, create a new machine. That should always trigger a full replacement, but there's actually nothing to say, I want to update the spec, but I want you to error if you're unable to do this as an in-place operation. And that's explained a little bit in the proposal, because I thought it was I thought if we had that functionality and say, updating the spec should always be an in-place, should always result in an in-place actuation. And if you ever want a full replacement, you should delete and recreate the machine. Then I think it's just going to create this pattern in every tool that's built on top of the cluster API to say, well, first, we're going to attempt to upgrade in place because that's going to be the faster operation. But I really want this changed anyway. So if I see an error there, I'm just going to replace the machine anyway. So it seemed like a more powerful concept to say, it's implementation specific, whether it's capable of doing it in place or if it has to do an upgrade. And then you just say, here's the new state of that machine, make it so. But if anyone has other ideas, feel free to chime in.
I had an idea, which is I personally don't think it is necessary to do at this time, but we don't really have this concept, I think, in the Kubernetes API of like a feedback of a post change. But one way we could do it declaratively is we could say, am I allowed to do a destroy restart? So in other words, and then you can imagine a sophisticated controller that like sets that during your maintenance window or whatever it is and like rolls it and does all sorts of fancy stuff. But the nice thing about that is that we can add it later if we need it.
Yeah, the one thing I wanted to bring up is if, like right now, pods, if a pod gets deleted and recreated, the name of the pod changes. And I think with this proposal, the machine name would stay the same even if the underlying machine got deleted and replaced. And so you have, a different boot disk. If you've logged into a machine and made any customizations, you can't tell from the fact that the machine name is the same that it's actually been replaced because you declaratively changed a field. Is that a concern, right? Do we want machine names to be tied to the fact that a machine is something that has like a boot disk and might have things on that boot disk and might have local storage of pods? Or do we say a machine is, more like a replica set of size 1-ish, where like the underlying thing that implements that machine can be replaced and we don't care about that, and like the definition of the abstract machine is what persists? Do people have thoughts one way or the other?
That is certainly weird. That had not occurred to me. Like I was imagining that the name would be the instance ID. I mean, at least for AWS, we can tag. There is a concept in the AWS control panel that the name tag is special and will appear as like the name of the machine in the UI. Doesn't actually mean anything anywhere else, but there is certainly that notion of a name separate from the instance ID, that you can give two things the same name if you want to, right? They don't really mean anything. So it's fine. I imagine that when we build up the higher level concept, we will like tidy that up a little bit.
One other simplification we can make now, which I would be completely happy for, would be someone from I think Archon side of things chimed in on the PR and said the way they had represented things was much more like pod in that it's completely immutable. You can't change any fields. And so if you want to change anything, you always delete and recreate. So I think ultimately it would be hard for many providers and installers to get on board if it was just completely impossible to do upgrades. Like that seems like such a great feature to be able to have and express, but we don't have to have that support now. So we can always change the definition in the future to say, okay, now you can update the kubelet version and these sorts of things can happen. But right out of the gate for V1 Alpha 1, we could just say these are completely immutable and any changes have to be a deletion recreate just to get us moving.
I mean, it is interesting because there's kind of a movement for immutable infrastructure, right? Which that aligns with where, it's idempotent, right? If you try to create a machine that looks like X, you already have one of those. Great, it just succeeds. It's there. It could not have been changed under the covers, right? But I think you're right that in the fullness of time, where like immutable is great in terms of simplification, but in terms of efficiency for things like upgrades, like I think we're going to want to support in-place upgrades on the road.
Yeah, especially if it means that you don't have to evict any pods. If you're able to quickly swap the kubelet and none of your workloads even notice.
Exactly, right? Or even like the container runtime in the future, now that newer versions of Docker can be swapped out without killing all the containers, right? Like you could imagine upgrading quite a few things in place on your nodes while just leaving all the workloads running without noticing. I think we want to strive towards that future.
I think what I would like to move towards is a solution where the provider can choose what's quicker, and if it's if an in-place upgrade is possible, it's fine. If it has to reinstall, then do that. But I think we should advocate for a position where machines like that have the same spec are pretty much fundable. So you don't have people SSHing and just modifying the boot partition of a node. No, you should put stuff that you need to do, like special one-offs like that, in like the provider-specific init config or whatever. Say, hey, when you create this machine, or whenever you have to recreate this machine, always run this modification to the local node. That way, if it does an in-place upgrade, great, it's quick, but if it actually has to recreate the VM or machine or reinstall it or whatever, it does reapply those changes that you needed.
Yeah, sounds good with me. That's how I'd written it in the proposal. Justin brought up an interesting question about the relationship between the name of the machine and the Kubernetes API and what the instance name will be in your actual provider. I had completely punted that to, well, every provider can just do exactly what they want, and I don't have to worry about it right now. But is that a reasonable assumption? It seems like you can absolutely do that, and if you can do in-place upgrades, and if someone tries to update a machine spec and you don't support in-place upgrades, and this VM is already in use and you have to cycle it, you could just update the status to say, sorry, this is an error condition. You need to delete this machine and create a new one, and I'll be happy to do that. And then any tooling that's built on top of this should be watching for errors and realize that it should try to swap machines instead of doing the normal like update of a spec. But is there a different way we could handle this, Justin, that you can think of? Because the other thing is just have absolutely no binding or no strong binding between the machine's identity and the identity of the VM. Like that's completely internal state that the controller can figure out how to manage the mapping between them, and the same machine could have the same name and actually refer to logically different VMs over time as they get replaced.
Yeah, I think we should let the name be user controlled, even if we then build another layer on top that means it isn't in fact user controlled. And like we have provider ID in the node, right, which now uniquely identifies the cloud provider ID, like some sort of metadata that is a system owned primary key. And then yes, it would be up to the cloud provider whether they enforce some restriction on the name, but we can certainly say, hey, by the way, like look at AWS, like we can change the instance ID. So you probably don't want to put the instance ID in the name as a requirement because it would be really confusing after a machine replacement. But I certainly like the idea of like the status returning. If something cannot be updated at all, the status can reflect that, and the sufficiently smart controller can act on that.
Cool. So that's all I had on that. The PR is still open, still encouraging more feedback. The types are checked in so that we can start prototyping, and we have started prototyping against them to get even more feedback on the specific types. But provide feedback as you will whenever you get a chance, and move on to Chris, I guess, is next.
Sorry, I had a idea, a thought. Upgrades of like packages on the OS, where does that fit in the spectrum, or are we punting?
Yeah, this is something that I had gone down the rabbit hole on and thought like, hey, we could have very cloud init style. You can version everything. You can version your kernel. You can version every package that you care about. And maybe we want that super long term. It's something that I thoroughly punted on right now for V1 Alpha 1. You can still do it in the provider config, which is the cheat way of doing everything. But yeah, so if you wanted to change any of that, the way that I've been thinking about it is just bake a new OS image and rev the OS image, and not really support in-place upgrades. At least using this API, you can still use some other mechanism for now. But long term, like I've structured it so the machine has a versions struct and currently has the kubelet and the container runtime, but we could just have a generic map string for any other packages. And install them and have OS specific node agents that are running and actually watch for changes and know how to do apt-get upgrade or whatever to install, upgrade or downgrade your packages.
Yeah, it's sort of annoying because there's like you have AMIs or cloud images, but you don't really know what like timestamp of the Debian package, whatever it's called, like that release that really sort of refers to. And maybe we could do that, but yeah, that would certainly be provider specific. So. Because it forces us down the path of a full machine replacement to do, yeah. Okay.
Hi, this is Prateek. I actually have a quick question. Can you guys hear me?
Yes.
Yeah, so something which is not clear to me is like from the user's perspective, let's say I have 3 nodes running and I want to upgrade something specific on one particular node where my pods are also running at this moment. So I get this point that it is provider specific, that the upgrade of that node can be in place or not in, or it will replace the node basically. So if it replaces the node, that those pods need to be moved to this new node, and who's responsible for draining that node and moving those pods? Is it the tools like Kubicon, or is it something this API will provide?
So right now, based on the way the API is written, a deletion of a node or changing a node is strictly immediate. And if the client side tooling that is doing that replacement is updating the spec or deleting machine, creating machine, actually cares to be workload aware or be safe, which I think is probably one of the value adds we want to add in the tooling that's built on top of this. It's its responsibility to cordon the node and drain the workloads and before it actually changes those things, and can be as sophisticated as it wants to be. I definitely think post V1 Alpha 1 that server-side draining fits somewhere in here, that we should have a safe operation to say, I want to update this spec, and by the way, please safely drain the node so that none of my workloads are actually affected by this operation. But that was a simplification I had made for V1 Alpha 1.
Okay, thanks.
I actually think we might want to do it in the opposite way, where by default, if you change a thing that requires the machine to be replaced, like the controller should be cordoning and draining the node before deleting it. And maybe an annotation, you can say like force fast deletion or something, and we can skip that step. But I think, the behavior that most people want and or expect is for that to happen. Like you said, we should move it into the server side, but the server side can be the controller we have that's watching the machine's API. It doesn't have to be the Kubernetes API server where we put the drain functionality.
True. Yeah. Yes. I agree. I should say the way the API is stated, it doesn't give you control over it yet. So it is specific to your provider and the controllers that you're running. But yeah, it is probably more sensible that the prototype controllers that we write do it safely instead of just doing the fast and easy thing.
Sure. I mean, we do the fast and easy first, and then iterate towards doing it in a better fashion. And then I'll give the user the option to say, force fast, right? Force, skip the cord and skip the drain. Like, I just want you to get rid of the node as fast as you possibly can. We may actually also want something in the declarative API to indicate that you want a node to be cordoned or drained, right? Do we expect that to always kind of go through kubectl cordon node, or do you think you declaratively want to say, like, give me a machine and make it unschedulable? So, something else to think about down the road.
You should be able to create a machine in an unschedulable state just by adding the right annotation, right? Or is it a proper field now?
Well, there is a field in the node spec for unschedulable. I don't know if there's an equivalent taint or annotation or something to do the same, and I don't know which one's preferred over the other. But yeah, it's something we could just mirror, similar to the dynamic kubelet config. It's something we can mirror in the machine and just constantly copy over to the node spec if there's an associated node, and just let the rest of the existing code take care of it in the way that it already exists.
Yeah, I mean, again, kind of maybe not part of MVP, but something we should be thinking about as a use case.
We could also a controller could just choose to bring up every node tainted and then untaint it when it's ready.
Yeah, I feel like CoreOS was looking at doing that at some point.
It's much easier than the alternatives. This is the easy way.
From a branding perspective, you say it's the safe way, and then everyone gets on board.
All right. Any other comments on Jacob's PRs before we move on? Chris has the next agenda item, which is sort of the other half of the cluster API, which is the control plane side. So
just a really quick update. I wanted to point out to everyone here that it is out for review. I still have a document to type up along with it, but the spec is there. There have already been some comments, but I just want to make sure people are aware of this, that it exists, and are telling me how to correct it. And I went ahead and checked in a version of this to a temporary location so people could start playing around with it, types, and getting used to it. But any changes that are made to the review will be final. So this is the stuff that's checked in is just temporary.
Cool. Any specific open questions that you want to try to discuss now, or just let people take a first pass at the PR before we actually discuss it?
In general, I mean, not specific to mine, but to both of ours, I've seen concern that the provider config stuff is just going to be a dumping ground for everything since we can't get anything in the main API. But I just wanted to point out that any prevalent patterns that start appearing there are good candidates to be promoted. We just want to take a simplistic approach to the main API before we start overcomplicating it. And we are, in the future, more than willing to consider, oh, this is actually useful to a bunch of different people. Maybe it should be in the main API. It's basically come to the philosophy that it's easier to add than to take away.
Cool, totally agree. So Robert has the next item, but he's also typing right now.
And you have some background noise. So I just wanted to give a quick PSA that I went to the SIG cluster ops meeting last week and volunteered to give a short presentation / demo about the cluster API and the work that we're doing as part of this breakout group to that community. The primary goal for that is to get feedback from the ops community about sort of different operational patterns that they would like to see the cluster API support. If you look at sort of the pitch decks for the cluster API that we reviewed last week, we're really sort of focusing the API around sort of common ops scenarios. And upgrade is obviously sort of the most common one, but we believe that there are other sort of operational scenarios for people that are managing clusters once they get their cluster up and running, that we want a consistent experience across environments. And so, hopefully some operators will show up and talk about the ways that they currently are managing their clusters and different sort of things they need to do. And so we can think about feeding those in as requirements into this effort. So that's next week on November 2nd at 1 p.m. Pacific time, if people are interested in joining. If not, it should be recorded, and I can give a summary at this meeting the following week about feedback. And next, I signed Jacob up to do a demo because he has something prepared.
Sure. Let me share my screen, figure this out.
And while we're waiting for that to start, if other people have other agenda items, we have a half hour. I don't think the demo will take that long. So please add other items or questions to the end.
Cool. So can everyone see that?
Yep, I can see my notes.
All right. So I don't know. This wasn't really prepared for this meeting. It was prepared for internal sync with other people who are prototyping these things. But one of the things I did recently was I mentioned that I checked in all the types for the machines. I've actually now structured them a little better as machines v1 alpha 1. Figured out how to generate all the deep copy methods so I can use them with API machinery, and created CRD for them. Independently, we have already prototyped an installer using the cluster API. I think it's just it's loosely converting between the new proposal for the cluster API and what Kubicorn expects as a cluster API, and just delegates most everything to Kubicorn. So it's mostly for demo purposes right now. But this is new functionality that we want to add to the installer to register the new CRD for the prototype. We're not sure exactly long-term if we want to use API aggregation, but for right now, it's really easy to work with CRDs in the existing API server. So to register the machine CRD, let's see. I've gone through the types and actually added all the necessary JSON annotations. I found that marshalling and non-marshalling wasn't working unless I was very specific with all of these annotations. I was getting a lot of zero value fields when I pulled them out of the API server. Let's see what else. I have examples for just to actually call that code to create the CRD, and then a sample controller just to get the start of how you would start actuating against the machines API. I haven't done any of this for the control plane level because we just got the types for them. So for actual demo, come over here. Okay, so I have an existing cluster, happens to be a GKE cluster, but it could be any Kubernetes cluster, and I can look at current custom resource definitions, if I can spell. Kube, nothing. So I can now look at the example of this machine CRD installer. I've already compiled it, so this just takes a kubeconfig file to know the endpoint of the API server and how to authenticate against it. I have that set up in my kubeconfig. And the way this and the controller are written right now, they just take a kubeconfig file. They could be run outside of the cluster. They could be run in the cluster. They can be run on the master as normal processes. They can basically run anywhere. It doesn't assume anything about your environment. So now I've actually created CRD, and I'll show this again. So now I have, we can bike shed about what this should be called specifically, but I called it machines.clusterapi.kates.io. At this point, I can actually say kubectl get machines, which is pretty cool. There are no machines yet, but it's actually registered as a top-level plural. And if I want to create an example machine, actually, I'll do two things in parallel. Let me start up. I have this very simple machine controller, just as an example of how to get started. There's a lot of ugly client code in client.go, but at the controller level, I just have callbacks for what to happen when a specific machine is added or updated or deleted. And right now, I'm just printfing it. These get passed in as opaque objects, but you can cast them to the proper machine type, so you can interact with them in type-safe ways. So every time a machine is updated or created or deleted, I just print its name. But on update, I specifically pull out spec.versions.kubelets to show old and new, just to show how you might actuate these in place if you're not going to completely replace the VM. So with that code, I can just run machines controller, same kubectl file, SIG. And then while that's running, I have this super dumb example of what a GCE machine might look like. It just has a regular name, and I've completely punted on the provider config, all of the actual interesting bits for this particular cloud, but gave it some semi-random values for the kubelet, the container runtime, and gave it a role of it should be a node. And if I create that, you can see my controller actually gets triggered. It gets the message that the object was created. At this point, it should actually check to see if there's a VM that already matches this. If not, spin up a new VM, and then watch for new nodes being registered that it should tie together with that machine and point the machine status at that new node. Right now, it's doing nothing. But since it's created, I can say machines and actually see my machine listed. I can get that specific machine as YAML and see that all the metadata has been filled in. I can edit it. And so this is how we've been imagining the tooling being written on top of the cluster API, because in a completely cluster and cloud agnostic way, you can now declaratively say, for this node, I want the kubelet version to be 1.8.0. And my controller gets triggered, and the object was updated. It has the old Kubernetes version and the new one, and it could trigger an in-place upgrade or swap the VM, whatever. I can also, if the tooling that I'm writing on top of the cluster API that's watching the status of this machine sees that there's an error, it goes into an error state, and after some timeout it hasn't recovered, then it can just roll back. And the controller will notice this and actuate back in the reverse direction. I can delete that machine, and the deletion code should get triggered, which will actually deprovision the VM, which would unregister the node, and potentially do all of the safe eviction logic so that it doesn't just immediately rip it out of existence. The other thing that you can do is use, if you want to create a bunch of machines, even though we don't have a set, you can use the API machinery of generate name and give it a prefix instead. And now I can create a whole bunch of these. And each one, if it's a unique name, create another one, and get all machines. And then even though they all started with the same templates, I can still independently, if I'm writing in cluster upgrader, I might say, well, my policy for rolling out a Kubernetes node upgrade is that I'll start with exactly one machine, wait for it to be successful, and then I'll roll out to 2 machines, then 5 machines, and give you the right balance between speed and safety. I can write that tooling in an agnostic way by being able to, instead of at the set level, at the actual machine level, updating these completely independently, while watching to make sure that all of them ultimately get updated to the new spec that I want to roll out. And then I can also completely delete the custom resource. And it actually triggers the deletion of every object that was associated with that CRD. So nothing impressive at this point, but it helps us talk about what's above and below the cluster API, the things that are actually actuating it, the provider-specific controllers and what their responsibilities are, versus how the tooling that sits above it would interact with it. And also just gets a starting point to start writing the code to provision, deprovision VMs and such. So I did that mostly to sync with other team members on progress and share code, but hopefully that's actually somewhat interesting to other people on the call. So I should say all of that code is in my personal repository now. I had to jump through a lot of vendoring hoops to get all the dependencies I needed, and it's not properly modeled using dep, which is what we're using for all of our other dependencies. So I'm going to fix that and then push it upstream so other people can use it. But if anyone wants a link, I'll just put it in the chat window and you can start looking at the code. That's it for the demo.
Cool. Thanks, Jacob. That is the end of our agenda for today. Does anybody else have anything they want to talk about before we call it? Going once.
I just the CRDs. I think I fully support prototyping with CRDs, but I think we should do API machinery. It is eye-opening, but I think it is the correct, like the one which allows like evolution of versions, for example. And if we don't do that, we're in deep trouble.
Yeah, I agree with that. And I think that is the long-term plan, is to do some sort of API aggregation into the machine or cluster API. But again, this is just for prototyping and getting started with it. We will work to move towards that at a later date.
Yeah, it is not worth spending 2 weeks grappling with the API machinery to get this. Yeah, yet.
Yeah, I think Chris said it well. Let's get something up and running, and then we'll maybe in parallel work on putting it in the right spot. Once we've got it up and running enough that we can work against it.
I would argue that we get to it before like V1 Alpha 2, but definitely before beta.
Yes. Yeah. Anything else? All right. Thanks everyone for coming today. I'll upload the video to the SIG channel, and we'll see everyone next week. Take care.